day 7 of Python programming tutorial, and today we shall learn more about the modulus and double divide function. So let's just make up a variable a equals, and we'll call it 11, sorry, let's just call it 111, and we'll say b equals a modulo 10. Now let's just try to print b. Let's see what happens. Okay, we should have kept it 1 2 3 because yeah. Okay, let's just print and we get 3. So what happens when you do a number modulo 10? So basically number modulo 10 means that when you divide 10, when you divide this number by 10, you get the remainder, which is the ones digit. Or if you don't want to get into mathematics, just remember when you do a modulo 10, you get the value which is here, like which is in the ones place. You know, it could be a 9 and then you would get a 9. Okay, it could be 5 and you would get a 5. We could have an entirely big number and you'll just get the last digit. I hope that makes sense for now. Now let's do the double divide function. Now what does the double divide function do? So when you just divide normally, let's just put 5 and we'll divide by 2. Now when you try to print that in normally, if you try to do that in your phone on an online compiler, the thing that will happen is this. It's supposed to show 2.5 because 5 divided by 2 is 2.5. Yeah, right, I mean that makes sense. But if you do a double divide, then it will just show the quotient of the division, and let's just run it again, and then you get a 2. So what happens is double divide function removes the remainder. So if you were to have 1 2 3 and you double divide it by 10, then oops, yeah, oh, I closed off that, my bad. So if you had to do this, then you would get 12, which I mean kind of makes sense because the last digit just gets removed. Okay, that's the whole gist of it for right now. That's all you need to know for going on the next step. Okay, so we learnt about modulus and division. Now let's move on to palindrome numbers. What exactly is a palindrome number? So a palindrome number is a number that can be read forwards and backwards the same. So an example would be 676, which is equal to 676. I mean you could read it 676 like this or 676 like this. Another number would be 67876, and yeah, I mean if you invert this number, or if you were to look into a mirror, like if you were to look at this number through a mirror, it would remain the same. It's just a palindrome number. Okay, if you read it backwards, 67876, it's still the same. The 2-digit palindrome numbers are really easy: 11, 22, 33, and so on. But 3 digits are a bit more complex. 434 is the same as 434, and so on. Basically, if a number can be read backwards the same as it was forwards, then it's a palindrome number. And counter example would be 567. 567 if reversed is 765, which is not palindromic, it's not equal. Okay, let's just make up a program which takes in a number and tells you if it's palindromic or not. Let's just choose 89. We'll make a while loop. Now what is a while loop? A while loop just keeps on running until the situation or the condition given here doesn't turn false. Okay, so in this case the number is 89, which is greater than 0, so this loop shall run. Okay, also just for safe measures, we'll make a variable named sum and we'll make it a string. Okay, let's start with sum equals sum plus we'll convert the value that we are about to get into string. We'll just say n modulo 10. Now what happens, what does n modulo 10 mean? So 89 modulo 10 should be just 9. Okay, so we'll get the value 9, and then the value 9 would be added to sum. Okay, now we're just gonna say n equals n double divide, or the forceful divide as I like to call it, and we'll just do that by 10. So now n was 89, double divide 10, then it should just be 8, and now that's the value of n. Okay, now the loop ends. Now it goes back to the top while n greater than 0. Is 8 greater than 0? Yes, of course 8 is greater than 0. Then the loop shall run again. Now the value of sum right now is 9. So 9 plus string of n modulo 10. So n right now is 8. 8 modulo 10 is 8 itself, that's it. So the sum got converted to 8 plus 9. Now it's a string. So 8 plus 9 wouldn't be 17, but 8 plus 9 would be 89, because you are just joining them as strings. Remember, there's a string here. Okay, now n equals 8 forceful divide 10. Now that should be 0. Then we run the loop again. Is 0 greater than 0? That's false. So this loop will not run, and then this loop will break. We can just print the sum. Okay, let's see that. And 89, the inverse of 89 is 98. Sure. Okay, let's just add this line. We'll convert it back to int. Okay, now we could just say if okay, now the n was converted back to 0, so we should have a temp variable. We'll just call it temp equals n. So we could just store the value of n somewhere else too, in the n to compare. Okay, that's a lot of n. Temp equals sum. Just print. It is a palindrome. Yay! Now let's try that. Okay, we should also print sum and also the temp. Okay. Although we are already inputting that number, so this shouldn't be an issue. This is the new number plus stringify it. Yeah, that's what I call it. And space, and oh, this shouldn't be inside here. It should be here. And yeah, let's try this. This is the new number 98, which does not equal 89, so it's not a palindrome. Let's put a number that's actually palindrome. Let's try 67676. It is a palindrome. Yes, it is. Okay, so we made a program which takes in a number, then finds the reverse of that number, and compares the reverse of that number to the main number. If it's the same, then it's a palindrome. Okay, let's just clean the code a bit up. We'll make a function is palindrome. It'll take a value n, and then this entire looping structure should be inside it. I'll just put the entire thing, why not? Okay, and this and some, yeah, seems to be fine. We need to cut this and put this inside too. Make sure you guys tab over. If there's a space here, that means this entire thing is inside this function. Okay, a lot of you also made this mistake. So yeah, and we'll not print this stuff. We'll just return, just say if temp equals the sum, then return true. Okay, so we just converted this entire function into a boolean thing. It's a thing, believe me, you don't want to get into it. It's the thing, it's a boolean. We'll go into booleans later. Okay, now the function doesn't do anything. It's just a black box. We can just collapse it, and yeah, we can just now check, is palindrome 909. Is 909 a palindrome? we'll just print, and it should say true. True, 909 is a palindrome. Perfect. We'll just remove this n, and yeah, that's it. This is how you check if a number is palindrome or not. Let's go one more step. Let's make up a function which prints palindrome. Okay, so as usual, it will take a minimum and a maximum value, and we'll just learn a for loop for I in range. See, once you make a function which checks for palindrome, it's really easy to print out all the palindrome numbers. Okay, we'll just put a minimum and a max plus 1 if is palindrome. Then, well, if it's a palindrome, then just do what you're supposed to do and print I. Well, what is palindrome? I. Just do this, cut, and we'll just delete this, and let's see. Oh, we should also call the function. See, calling a function is really important. So we'll give a minimum value of 1, and that's a bit too much. 1000. Okay, let's try 1000. Okay, these are all the palindromic numbers. Obviously 1, 2, 3, 4, 5, 6, 7, 8, 9 are here because 1 is the same as read backwards as forwards. So yeah, I mean, that's not much interesting. We could go for 10,000 to 11,000. Let's see what kind of numbers do we get. So these are the palindromic numbers. There's a lot of stuff that you could do here. This is really fun stuff, and have fun. See, we just printed all the palindromic numbers between 10,000 and 20,000. So, yeah, these are the palindromic numbers. So any questions, comments, concerns, anything at all, feel free to reach me out in the comments, and I hope you had fun.